Okay, with multiplication and division, rational expressions, you're basically going to do two things. You're going to factor and cancel. That the multiplication you're really not multiplying, you're still just mostly factoring when you're going through the parts of this one. And with the different problems, they're probably going to start you off with a couple of different things. Well, let's give you one something like this. Let's go with 3x plus 6 over 5x plus 2. And then times 3x plus 18 over x plus 2. Now, and again, the first thing is when you're doing this, when you're not going to do the full method and go through everything here. And again, the one thing you want to kind of think of is that when you're doing this part, everything here that's got pluses or minuses, you can put those in parentheses. And if you're going to cancel, you have to have exactly the same thing in the parentheses to go back to cancel. So if you don't have the same thing here, that's when you're looking to factor. 3x plus 6, you can divide them both by 3. Make that x plus 2. On the bottom, you've got the 5x plus 2, and there's nothing you can cancel there, so it's pretty much going to stay that way. On the top with this one, we've got 3x and 18. You can divide them both by 3. So if you divide out the 3, make it x plus 6. On the bottom, we've got an x plus 2. So even though it says to do multiplication, you're really not going to multiply. You're going to factor what you can, and then you cancel what you can. Get rid of the x plus 2's. And for that one, that's it. So on the top part, you're left with 3 times 3. So that would be a 9. You've got the x plus 6 that's left over. On the bottom part, you're left with a 5x plus 2. And since there's nothing else on the bottom, you don't have to put the parentheses in there. You can just leave it as 5x plus 2. Okay, a little bit different of a look here. So this one will throw two variables at you. You've got 6m minus 6n over 35n and times 5 over m squared minus n squared. And for this one, the only parentheses you really would need to add in would basically be here and there, because those have the pluses and minuses. The 35 and the 5, there's no pluses or minuses on those, so you don't have to put any parentheses there for that part. Okay, on the top part, you've got 6m and 6n. You can take out a 6, and that's going to leave you with an m minus n. 35n, again, nothing you can do with that part. It'll stay like it is. Same thing with the 5. It'll stay like it is. And m squared minus n squared. We've done one like that. It just looked a little bit different. It's the difference of two squares, right? The difference is now it's not 4 at the end or 9 or 25. It's m squared and n squared. So when you factor this one, it's going to be m plus n and m minus n. So for that second one, the squared was, instead of it being a number, it's a variable, but it's still the difference of two perfect squares. And now you can start canceling. You've got the m minus n that's here and there. Take those out. 6 and 35, you're not able to simplify that one, but you can do 5 and 35. Divide them both by 5 and make that a 1. Make that a 7. So in the numerator, you've got 6, that cancels. You've got 6 times 1 for 6. In the denominator, you've got the 7, still got the n, and then you've got the parentheses, m plus n. Say it again. Not necessarily, no. Sure. With the two variables. Let's go with x squared plus x minus 6 over 3x minus 9. And we'll go times x minus 3, and that's over x squared minus 3x plus 2. Okay, same thing on this one. There's no really multiplication you're going to do. You're factoring everything. And because there's pluses and minuses everywhere, you've got to think about all those terms being in parentheses. Okay, starting on the top left, we've got x squared plus x minus 6. You've got to find the factors of negative 6. And you're looking for the pair that's going to have a sum of basically a positive 1. Not going to be 1 and 6, because if you add or subtract, you get 5 or 7. So it's got to be 2 and 3. And since the sign here is positive, the bigger number has to be positive. And if you do a negative 6 divided by a positive 3, it's going to have to be a negative 2. So when we factor this one, we're going to have an x minus 2 and an x plus 3. Okay, underneath that one. This one is there's only x to the first power, so you're only going to have one and that's kind of the way you think about it here. If you have x squared, you're probably going to need 2 parentheses, because if you set both of those equal to 0, you'd have your 2 answers. If it's x to the first power, you're only going to have 1 parentheses, because there's only one x. So for this one, the only thing you can do is you've got 3 and 9, just divide them both by 3. So take the 3 out, that'll leave you with an x minus 3. For the top part on the right-hand side, it's x minus 3. There's nothing you can do for that one, so it pretty much stays there. And on this one, you're looking for the factors of positive 2. You want the sum to be negative 3. And again, there's only one option. It's got to be 1 times 2. And because the b term is negative, bigger number is negative, positive divided by negative makes the other one out to be a negative. So the biggest thing you're doing in all the multiplication and division, it's just your factoring skills. It's taking all the factoring we were doing in chapter 6, and you're just working it over, and now you're going to go back and cancel. You've got an x minus 2 and an x minus 2. Those are gone. You've got an x minus 3 here, x minus 3 here. And everything left over, we've got an x plus 3 on the top. And there's nothing else other than, we can go back and put 1s in the place where we go back and cancel all these. So there's just x plus 3 on the top. On the bottom, you've got this 3 and that x minus 1. That'll be your final answer. Yep. Is that good? Okay. For this problem, you've got to factor and cancel everything you can do. Now, this one I've got it in blue for a reason, because that's the one you're going to have to do the most work on. The x plus 5, nothing you can do there. The 2x plus 21, nothing you can do there because it's 2 and 21. The only one you can do any work with for this part is a 3x plus 12. You can divide both of those by 3. So if you divide 3 out of both of those, that's going to leave you with an x and a 4. All right, and we've got the x plus 5 here. Now, the blue part, that's the part that you are going to have to factor. And different from most of the problems we've seen so far, the first term is 3. And there's nothing, you cannot divide 3 into 14 or 8. So that one, you cannot take out a greatest common factor. That part, you are going to have to do bottoms up. So first thing is, you're going to do 3 times 8 to get 24. So you're going to find the factors of 24 where the sum is going to equal negative 14. Again, go through the list. You've got 1 and 24, 2 and 12, 3 and 8, or 4 and 6. And since the sum, the b term is negative, again, that sign goes on the bigger number. And when we did 3 times 8, both of those were positive, so that would be a positive 24. So if you do a positive divide by negative, that means the other sign is going to have to be a negative. So now we're going to find the pair that adds up to 14. It's going to have to be 2 and 12. Now, and up till now, everything we've done so far today, we would go back in, we'd put x minus 2, and we would put x minus 12. But remember, for this one, here was the one thing that was different about this one. We did 3 times 8 in the beginning, right? To get this number. If you go back and check it real quick, you've got x times x, that's x squared. It's got to be 3x squared. If you did 2 times 12, that's 24. The last number's got to be 8. So the numbers are too big right now. Or some of them are too small. So it's not evened out. Because we multiplied by 3 in the beginning, now you got to go back and divide by 3. So for this part, you've got 12 divided by 3, that becomes 4. 2/3. Nothing you can do to simplify that one. So if we were doing bottoms up, since that won't simplify, pull the 3 up in front of the x. And make it 3x minus 2. So when we're factoring this part that's in blue, it's the toughest one we've had to do so far. That's going to become 3x minus 2. And x minus 4. Now that we've got that blue part factored, the numerator that was over here, now we get to go back and start canceling out the different parts and pieces that we have. The only thing that we have in common, though, is that x minus 4 that's here and here. So once we cancel those two things out, that's it, right? Because, you know, the x plus 5, nothing even close here. The 3x minus 2, you may say, well, what about the 3's? Well, again, that one's in parentheses, that one's not, so there's nothing you can do there. So it seems like you could get more out of it, but that's all you can do. So the final answer would be 3x minus 2. That canceled. We've got a 2x and plus 21. On the bottom, we've got an x plus 5 times 3. And you can put the 3 at the end, but most of the time we're used to seeing it in the front, so we'll go back and put it over here. Okay, so again, we haven't really seen one of those with having to do the AC method. We did it last time, but every problem we did today, we just did have to do the short factoring or take out a greatest common factor. So just to make sure everybody remembers what was going on, there's one if you have to take. So factor. See, once you find the factors, you've got to go back and even out and divide both of those factors by the A term, which in this case was 3. Okay, and for the second part, with division. That when you're going through with the division part of it, it's pretty much it's the same thing as multiplication, but one thing different. And let's kind of go back, and again, I hate to go back to 6th grade and 7th grade math, but most of algebra that we do is based on 6th and 7th grade math. Before we do the expressions, let's take it back to, let's say you had something like 4/5 divided by 2/3. Just throwing out some numbers there. All right, get back in your Wayback Machine. Go back to 6th grade math. How do you do that problem? Everybody may have learned something different. We always taught it that you keep it, you change it, and you flip it, right? So you keep the first fraction the same, change the division to multiplication, and then you flip this second fraction upside down. Now it's a multiplication problem, right? That's exactly the same thing we're going to do with expressions. Is you're going to start with a division problem. You're going to keep the first fraction, change the division multiplication, flip the second fraction upside down. Now it's a multiplication problem, and then you're going to do it the exact same way. So, if we can follow this one out. 4 and 2, you can divide them both by 2. So you're left with 2 times 3, which would be 6. 5 times 1 would be 5. So even though we're going to start with a division problem, we're going to keep it, change it, flip it. Now you got a multiplication problem. Do it exactly the same way as you're going through this part. And every time we do KCF, I always want to go to KFC and get chicken. So. All right, here we go. Let's give you an actual expression, not one with just the numbers in here. So let's go with x squared minus 2x minus 3. And that's over x plus 2 divided by 3x minus 9. And x minus 2. Oops, sorry, actually make that an x plus 2. Okay, and the directions on those problems will be really simple. Here you go, divide. That's the only thing it's going to say. All right, but the very first thing you want to do is keep, change, flip. So keep the first fraction exactly like it is. Change your division to multiplication, and then flip this thing upside down. Technically, you're taking the reciprocal of the second fraction, but just to keep the short version of keep, change, flip. And once you've flipped this thing upside down and made it a multiplication problem, now you're going to do the same thing. Factor everything out, cancel out what you can cancel. Okay, so for this one, on the bottom, x plus 2, nothing you can do there. We'll leave it there. And again, if you want to go ahead and put parentheses around it, we can, just to make sure we've got it here. X squared minus 2x minus 3. There's only one way you can factor 3. It's got to be 3 times 1. So now it's just a matter of getting the signs in the right place. And since the b term is negative, the bigger number has to be negative. And if you divide a negative and a negative, makes the one a positive. X plus 2 is good. Nothing you can do to break it down. And on the bottom part, 3x minus 9. Both multiples of 3, so divide it by 3. Okay, and start canceling. You've got an x plus 2 here, x plus 2 there. Got an x minus 3 here, and x minus 3 here. So you're left with an x plus 1 on the top, and a 3 on the bottom. All right, so let's give you a good one here to work on. Let's go 15x squared plus 13x plus 2 over 4x minus 12 divided by 5x squared plus 36x plus 7. And that's over x minus 3. Now, and again, sometimes people try to do too much at the same time. If you're one of those people, don't do too many things at the same time. Try to keep it pretty simple. But let's go keep, change, flip first. So we've got this part here, just rewriting it. Change the division multiplication and flip this thing upside down so the x minus 3 is on top, and then the 5x squared plus 36x plus 7 is on the bottom. Okay, now that we've got it in the right order, now let's go back and actually start taking this thing and break it down and factoring it one piece at a time. Very first top one we've got here, with the 15x plus x squared plus 13x plus 2. Definitely not going to be able to divide everything by 15, so this one you're going to have to do the AC method. So we're going to start off by doing 15 times 2, which is 30. So we're going to look for the factors of 30. And we'll look for the pair where the sum is going to equal 13. The good thing about this one is that all the terms are positive, so we don't have to worry about any negatives, that everything we're going to be adding them together. So it's either 1 and 30, 2 and 15, 3 and 10, or 5 and 6. And since it's all positive, we don't have to worry about any signs. The pair that adds up to 13 is going to be 3 and 10. So that'll be x plus 3 and x plus 10. Again, the one catch on this one is because the first number was 15, and we had to multiply 15 times the 2 to get 30, we've got to go back and divide by 15. And both of those, and this is kind of the first one we've seen so far, both of those fractions simplify. So you get 3 over 15. That becomes 1/5. 10 over 15. That one becomes 2/3. So we simplified those fractions as much as we can. There's nothing else we can do. So now we're going to pull up both numbers. This 5 is going to go in front of the x. This 3 is going to go in front of that x. So once we've taken this one and broken it down, now that's the expression we're going to have to put in there. Okay, and we're also going to go ahead, while we're kind of working these out, we're going to do the same thing with this one because it's the same setup. We've got a 5 here, we've got 36, so there's no greatest common factor, so for this one we're going to have to do the exact same thing, that we're going to have to do 5 times 7 to get 35, and we're looking for the factors of 35. They're going to add up to be positive 36. And there's only 2 choices. If you check 35, it seems like there should be more on 35, but there's only 2. It's either 1 times 35 or it's 5 times 7. They're all positive, so the pair that's going to add up to 36 is going to be the 1 and the 35. And again, because we had to do the a times c in the beginning, we multiplied by 5 to get it started. We're going to do the same thing again. We're going to have to go back and divide by 5. 35 divided by 5 on that one makes x plus 7. 1/5, it's done all you can do. So take that 5, pull it up in front of x, and make it 5x plus 1. Okay, the x minus 3 here, nothing you can do there. The 4x minus 12, that one we'll be able to take out of 4. We've done a lot of work, so let's kind of start this thing over here. So for the top part here, we've got the 5x plus 1. So we can get it all back together here. So we've got this part is our numerator. We had 4x minus 12. That part we could take and divide out the 4. So if we do that, it makes it 4 times x minus 3. Okay, this one was x minus 3 over here, so nothing you could do to factor that part. And this one, that's where we factored this, so that's where we're going to pull this down here and make that 5x plus 1 and x plus 7. Okay, so that all that stuff in the middle was the work of factoring those two that didn't have the first term as 1, and it didn't factor, so we had to go back and do the AC method in the middle. So that was the part we had here, that was the part we had that went here, and this one just had a 4x minus 12, so we just divided both of them by 4. Okay, we've done all that factor, now let's cancel some stuff. 5x plus 1 is gone here and here. You've got the x minus 3 that's here and here, and that's it. So we've got a 3x plus 2 that was on top. There's nothing else there, so we don't need that parentheses. On the bottom, we've got the 4 and an x plus 7, and we finally get the answer we're looking for there. What's that? Is complex fractions. And for the complex fractions, they're only going to give you one thing. They're going to ask you to simplify. And it's kind of similar to the last thing we were doing. And on these, they're not going to get too awfully complicated with the problems. They're going to give you something like this. 4 over 8/3. And the part that makes it complex is you've got a fraction inside a fraction as you're going through this thing. Now, here's what we're going to do. We're going to take it back to 6th grade math again. All we're going to do is we're going to rewrite this, because technically this is 4 divided by 8/3. And guess what we're going to do? Keep it, change it, flip it, right? So we're going to keep this fraction or this number the same. We're going to change that division and multiplication, and then you flip it. So the 4 stays 4. Change the division, multiplication, and flip this upside down. And for the people that are going, but you've got a whole number and you've got a fraction. All right? How do you take any whole number and make it into a fraction? There you go. Put it over 1. Now you've got 2 fractions. Now you can multiply and be happy, right? Or as happy as you can be that you have fractions. Okay, 4 and 8. You can divide them both by 4. 4 going to 4 one time. 4 going to 8 2 times. You're left with 3 times 2. Just leave this 3/2. Don't worry about making it into mixed numbers. Don't make it into decimal numbers. As long as it's simplified as much as you can leave it simplified, just leave it as 3/2 or 5/7 or 8/6 or 8/5, whatever the fraction is. As long as it's in simplest form, you don't have to make it into mixed numbers. And about the only other thing they can do on those is do something like this, where you've got a 1/2 over 3/16. But it's still the exact same setup, because it's technically, it's 1/2 divided by 3/16. So for that one again, if you keep it, change it, and flip it, well, now you've got 1/2 times 16/3. 2 and 16, you can divide both of those by 2. So you're left with 8/3. It's in simplest form, so that's all you got to do.